You're listening to DTFHN for March 1st, 2026. I'm your load-bearing host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people argue about whether understanding things still matters. Today's feed is restless, curious, and quietly furious about the right stuff. Water your plants, and let's go. What does it actually mean to be good at something when the definition of good changes underneath you? This is a question the software engineering profession is wrestling with right now, and it has a precise historical parallel. In 1987, when spreadsheet software became ubiquitous, accountants didn't disappear, but the ones who defined their craft as being fast at arithmetic found themselves disoriented. The profession didn't shrink, it shifted. The valuable skill became knowing what to calculate, not how to calculate it. And the transition was brutal for people who'd spent decades building identity around the how. Øyvind Kolås wrote a piece that captures this moment for software engineers with uncomfortable clarity. A Harvard Business Review study tracked 200 employees at a tech company over 8 months. 83% said A, increased their workload, not decreased, increased. They didn't use the tools to finish early. They used them to attempt more, broader scope, faster pace, longer hours. A self-reinforcing cycle where acceleration just meant more surface area to cover. The engineering craft parallel that matters here is what happened at Bell Labs in the 1960s. When they moved from hand-wired circuits to computer-aided design. The engineers who thrived weren't the ones who learned CAD fastest. They were the ones who understood signal integrity, thermal dynamics, the physics underneath the abstraction. The tool automated the drawing. It could not automate the judgment about what to draw. That's exactly where we are. The Harvard study found burnout at 62% among associates and entry-level engineers. Among C-suite leadership, 38%. The people setting expectations and the people carrying the weight are living in different realities. 43% of engineers in a separate survey said leadership was out of touch with team challenges. Over a third reported productivity had actually decreased even as AI investment increased. Here's what deserves genuine admiration in this moment. The engineers navigating this transition well are developing something extraordinarily difficult. The ability to hold an entire system in their head while delegating the mechanical expression of it to a tool that doesn't understand context the way they do. That's not a lesser skill than writing code by hand. It might be a harder one. It requires taste, architectural judgment, and the discipline to verify what you didn't personally construct. The real question this raises is whether organizations will recognize that the new complexity deserves new support structures, or whether they'll keep celebrating the productivity gains while the people generating them quietly burn out. The tools exist. The challenge was never technical. It's whether leadership can close the gap between what they believe is happening and what their engineers are actually experiencing. Moving on! One commenter on this demo pointed out something genuinely unsettling. They said the real danger isn't the obvious ad. The banner, the pop-up, the sponsored reply you can spot from orbit. The real danger is when you can't tell the difference between the ad and the answer. And that's the whole game, isn't it? This developer built a satirical demo showing every obnoxious ad pattern bolted onto a chat interface. Pre-roll banners, mid-conversation product placements, sponsored suggestions. And the Hacker News crowd looked at it and mostly shrugged. Easy to detect. Easy to block. Next, let me play devil's advocate for a moment. What if the shrugging is the problem? We've trained ourselves to recognize display ads. We built ad blockers that strip them in milliseconds. We feel clever about it. But chat interfaces aren't web pages. When you ask a question and the model weaves a product recommendation into paragraph 3 of a 5-paragraph answer, there's no DOM element to block. There's no border around the sponsored content. The ad is the content. The response itself becomes the delivery mechanism, and your ad blocker is sitting there with nothing to filter because the manipulation lives inside the language model's weights. Baked in at training time or injected at inference through system prompts you never see. Someone else in the comments made the competition argument. If ChatGPT does this, just switch to Claude, and if they all do it, open source will save us. Which fine, that's the right instinct. But run it forward. The compute costs for frontier models are enormous and climbing. The companies burning billions on inference aren't doing it for the love of knowledge. They need revenue. And the ones who resist ads the longest are the ones most likely to fold or get acquired by someone who won't. This is actually one of those cases where the open versus closed distinction matters in a way that's almost boringly literal. If the model is open, you can audit what it's telling you and why. If it's closed, you're trusting the company running it to keep the wall between answers and advertisers intact. That wall has held exactly 0 times in the history of ad-supported technology. The demo itself is funny. The irony that the site hosting the satire is also aggressively trying to sell you something. That's the kind of recursive joke the internet specializes in. But the laughter covers something worth taking seriously. The question isn't whether AI chat gets ads. It's whether you'll be able to tell when it happens. The obvious ads are a distraction. The subtle ones are the product. 3 stories in, and we haven't even hit the small stuff yet. Story 3. Microgpt. Let me make the strongest case against what Anthropic just did. 200 lines of Python that trains a GPT. No dependencies. Fits on a single screen. The counter-argument writes itself, this is a toy. It trains on baby names. It can't hold a conversation. Can't reason. Can't do anything remotely useful. Real language models require billions of dollars, thousands of GPUs, and teams of hundreds. Distilling that down to something a college freshman could read in an afternoon. Isn't that just a parlor trick? A beautiful one. Sure, but ultimately misleading about what these systems actually are? Here's where that argument collapses on its own terms. The entire history of computing is parlor tricks that turned out to be blueprints. Unix started as a side project, on a borrowed PDP-7. The first web server was one guy's next cube. Every system that eventually ate the world started as something a skeptic could dismiss as a toy. The question was never whether the toy was production-ready. The question was whether it contained the essential idea. And Microgpt does. Every algorithmic component of a Java large language model. Tokenizer, autograd engine, transformer architecture, atom optimizer, training loop, inference loop. I'm present and readable, everything else, Karpathy says, is just efficiency. He cannot simplify it further. That word, tanad, is doing extraordinary work in that sentence. A decade of iteration across Microgpt, MakeMore, NanoGPT, each one stripping away another layer of accidental complexity until what remains is the irreducible core. This is what crystallization looks like in software. Not adding features. Removing everything that isn't load-bearing. Now, run this through the bootstrapism lens. Who can touch this? Anyone. Anyone with a Python interpreter and an internet connection. No API key, no subscription, no terms of service that change on a Tuesday. No compute cluster. The entire mechanism that powers the most transformative technology of the decade, laid bare in a file you could print on 3 pages and tape to your wall. One commenter transliterated it to Rust as a learning exercise. Another built an interactive visualization. A Korean developer adapted it to generate Korean names. The thing is already propagating, mutating, teaching. This is how the ladder stays where people can reach it, not by arguing about access policies or licensing frameworks, but by making the knowledge so compact, so elegant, so portable that gatekeeping becomes structurally impossible. You can't restrict what fits in a GitHub gist. You can't paywall what someone already memorized. The unintended comedy here, and there is comedy, is that the most powerful AI companies on Earth are spending billions to build something whose fundamental mechanism can be explained in 200 lines by one guy who used to work at most of them. The emperor's new clothes aren't the algorithm. They're the infrastructure moat everyone pretends is a scientific one. Carpathy just published the pattern. The rest is scale. And scale, historically, is a problem that solves itself once enough people understand what they're scaling. So, what happens when someone who understands the fundamentals decides to rebuild something as basic as a terminal? Story 4. Ghostty. A terminal emulator just mass-compiled on every Linux distribution that matters. And the reason it matters has nothing to do with terminals. Ghostty is written in Zig. It renders through the GPU. It uses platform-native UI on every operating system it touches, which means on macOS, it's a real macOS app. On Linux, it's a real GTK app. 0 configuration to start. That's the pitch. But the pitch isn't why this is on the front page of Hacker News again, for what feels like the 20th time. The interesting question is, what happens when someone builds infrastructure with the same philosophy you'd bring to a library or a protocol? Ghostty is MIT licensed. The entire rendering pipeline, the configuration system, the platform abstraction layer, all of it is inspectable. You can read exactly how to achieve sub-millisecond frame latency. You can trace the path from key press to pixel. And because it's Zig, not C, not C++, the codebase is readable by humans who weren't there when it was written. That's a design choice with consequences. The terminal emulator market, if you can call it that, already has strong contenders. Kitty has been doing GPU-accelerated rendering for years. WesTerm gives you Lua scripting and multiplexing built in. Alacrity proved the concept that a terminal could be fast enough to notice. Each of these is open source. Each of them pushed the others to be better. And now Ghostty walks in with a fresh implementation that sidesteps the accumulated technical debt of every predecessor and says, here's what this looks like when you start from zero with modern tooling. So, the comments are telling. People aren't debating whether Ghostty is good. They're debating whether it's better than their current favorite. That's the mark of a category where open competition is working exactly as designed. 4GPU accelerated open source terminal emulators, each with a different architectural thesis, each forcing the others to sharpen. No vendor lock-in, no subscription model, no telemetry debates. This is what infrastructure competition looks like when the barriers to entry are skill and taste rather than capital and access. Someone had a clear vision for how a terminal should work, wrote it in a language designed for clarity, and shipped it where anyone can use it or learn from it. The blueprints are the product. The product is the blueprint's satellite. And the terminal you're reading this in probably just got a little bit better because Ghostty exists. Now for something completely different, from pixel-perfect terminals to the elegant math hiding in plain sight. Pause. Decision trees. In 1959, Arthur Samuel built a checkers program that could beat him at his own game. The technique was simple: a tree of decisions, each branch a question, each leaf an answer. No neural networks, no gradient descent, no GPU clusters. Just nested if-then rules, all the way down. 66 years later, the same basic structure remains one of the most deployed algorithms in production machine learning. That fact alone deserves a moment of genuine admiration. This interactive explainer from Amazon's MLU team walks you through building a decision tree from scratch, and the craft of it is remarkable. You're a farmer. You have tree trunks. You know diameter and height. From those two numbers alone, the algorithm carves decision boundaries that separate apple from cherry from oak with startling accuracy. Each split is chosen by measuring entropy, that beautiful inforting, that beautiful information, the theoretic concept that quantifies how mixed up your data is. Low entropy means purity. High entropy means confusion. The algorithm just keeps asking, where can I draw a line that reduces confusion the most? The question nobody in the current AI discourse wants to sit with is this: when did we decide that understanding how a model makes decisions stopped being a requirement? Decision trees give you something almost no modern system offers. You can trace every prediction back through every branch to the root. You can hand it to a regulator, a doctor, a judge, and say, here, this is exactly why the model said what it said. One commenter who worked at CERN noted that boosted decision trees dominated particle physics classification, specifically because physicists demanded explainability alongside power. The interactive visualization itself is worth studying as engineering. Clean, explorable, no login wall, no paywall, hosted on GitHub pages. The entire thing is open. You can fork it, learn from it, teach with it. This is what technical education looks like when the goal is comprehension rather than conversion. And there's a fascinating thread in the comments about single-bit neural networks being equivalent to decision trees, meaning you could theoretically compile a neural network into a chain of if-else statements. The boundary between these paradigms is blurrier than the marketing suggests. Maybe the most powerful thing about decision trees isn't their accuracy. Maybe it's that they re-fi you so doesn't hide their reasoning. In an era of trillion-parameter black boxes, an algorithm that shows its work isn't just useful, it's a political act. What happens when that same commitment to transparency meets creative tools? Story 6. Øyvind Kolås and the Future of GIMP. Øyvind Kolås chose his IRC nickname in 1995 because a hobbit named Pippin was too curious for his own good. Threw stones where he shouldn't have, stared into ancient seeing stones just to understand how they worked. 20 years later, that same curiosity produced the color engine running inside GIMP 3.0. GGL is the layer underneath GIMP that most users never see. It's a system that lets you chain image operations together, color correction into sharpening into transformation, as a directed graph rather than a stack of destructive edits. When GIMP 3.0 finally shipped non-destructive filters, the feature people had been requesting for over a decade, that was GGL. That was Pippin's work. But here's the origin story that matters. Kolås wasn't recruited. He wasn't hired. He was building his own video editor, experimenting with perspective transforms, and he noticed that GIMP's version produced aliasing artifacts under severe transformations. Moya patterns. Visual garbage. He had just solved the same problem in his own code, so he wrote a patch. Adaptive subdivision supersampling for the transform tools. That single contribution, born from noticing something was wrong and knowing enough to fix it, became his entry point into a project he'd maintained for decades. This is how open source actually works at the infrastructure level. Not grand declarations, not corporate philanthropy. Someone scratches their own itch, discovers the fix applies upstream, and contributes it back. The code base gets better. The next person who hits that moye problem never has to solve it again. Run this forward to the present. Kolås has spent years building GGL and Babel, the color space library, as public infrastructure. The comment that caught my attention was someone quoting him about having a couple hundred people who want him to keep writing and sharing code publicly. That sustains him. Roughly. The gap between sustains roughly and sustains comfortably is where open source still has unsolved problems. But the code exists. The architecture is open. Anyone can read it, fork it, learn from it, build on it. A curious hobbit who couldn't stop looking into things he probably shouldn't have. 20 years of patches later, millions of people edit images with his color math running underneath. Curiosity compounds when you let other people touch the output. Open source thrives on trust, pause, and now Anthropic is making the case that trust should extend to how we think about AI supply chains. This single word buried in OpenAI's statement that tells you everything you need to know. Not risk, not supply chain. The word is designated. OpenAI is publicly lobbying against a specific bureaucratic classification for their competitor. That's not generosity. That's strategy. Let me lay out what's actually happening here. Both Anthropic and OpenAI want contracts with the Department of Defense. Both companies have stated red lines, things their models won't do. Kill targeting, autonomous weapons deployment, the hard limits that separate a tool from a weapon. On paper, the policies look nearly identical, but the implementation diverges in a way that matters enormously. Anthropic wants to enforce those red lines through technical controls, hard-coded into the system. The model itself refuses. OpenAI's approach, based on what we can piece together from public statements and the comment thread on this, relies more heavily on contractual enforcement, legal agreements, trust. Run this forward 5 years. You have a frontier model deployed in a military context. The mission parameters shift. Someone with sufficient clearance decides the definition of lawful use needs to expand. With contractual enforcement, you draft a new memo. An attorney signs it. The red line moves. With technical enforcement, you have to go back to the model architecture. You have to change the system itself. That's not a memo. That's an engineering project with a paper trail and peer review. This is the architectural question that keeps not en masse. Not whether you have principles, but where those principles live. In a contract in a drawer, or in the weights and the inference pipeline. One of those is auditable. The other requires you to trust institutions that have historically earned exactly the amount of trust you'd expect from institutions with classified budgets and no external oversight. The reason OpenAI doesn't want Anthropic designated as a supply chain, risk isn't altruism. If Anthropic gets locked out on national security grounds, it sets a precedent that technical safety requirements, the very kind Anthropic champions, become a liability rather than an asset in government procurement. That precedent eventually comes for everyone, OpenAI included. The engineering choice is the governance choice. Where you put the guardrails determines who gets to move them. We talked earlier about who controls the tools. Story 8 is about making sure everyone knows how to build them. I built a chatbot once in about 300 lines of Python. Took a weekend. The thing could hold a conversation, summarize documents, answer questions about calculus. And the moment I finished, I had this disorienting realization. The gap between what I'd written and what powers the systems millions of people use every day was surprisingly narrow. The architecture is the same. The math is the same. The difference is scale, data, and compute. Not secret knowledge. Zico Coulter at Carnegie Mellon just made a course out of that realization. 10202, Introduction to Modern AI, Spring 2026. And the framing is worth paying attention to. The course description says it plainly. A minimal LLM implementation leverages a fairly small set of machine learning methods and can be written in a few hundred lines of code. That's not marketing. That's an accurate description of the state of the art. The syllabus walks from supervised learning through transformers, tokenizers, fine-tuning, alignment, reinforcement learning, all the way to safety and security. By the end, students build a working chatbot from scratch. The prerequisites are introductory programming and basic calculus. Not a PhD, not 3 years of linear algebra. 15-112 and 21-111. Courses most technical undergrads finish by sophomore year. The whole thing is available online. Free, 2 weeks behind the in-person version. Colab notebooks. Marimo notebooks. A grading system anyone can use. Pull the lens back. A top 5 computer science department just declared that understanding how modern AI actually works is an undergraduate level skill. The course exists because the knowledge barrier was always lower than the mystique suggested. The systems are complex at scale, but the principles are accessible to anyone willing to do the math and write the code. One commenter asked about symbolic reasoning. Fair question, wrong frame. This course isn't trying to be comprehensive. It's trying to be demystifying. And demystification is what matters right now, because every policy debate, every regulatory framework, every argument about AI risk is shaped by how many people in the room actually understand what a transformer does versus how many are working from metaphor and fear. Coulter put the blueprints on the table, notebooks, lectures, assignments, all of it. The tools exist. The knowledge is available. The only question is whether people pick them up. Moving on. In evolutionary biology, there's a phenomenon called habitat switching. An organism adapted to one environment doesn't gradually evolve into a new niche. It jumps. One generation, it's a freshwater fish. The next, it's tolerating brackish water. The adaptation isn't slow. It's a threshold event. Anthropic just built a threshold event for AI users. The mechanic is almost comically simple. You go to your current provider, ask it to dump everything it knows about you, copy the text, paste it into Claude. Done. Your preferences, your communication style, your check context, all of it migrates in about 30 seconds. No API wrangling, no export format, no ticket to support. Copy, paste, continue. Now here's the comedy of unintended consequences. To use this feature, you have to ask your current AI to confess everything it's been quietly storing about you, every preference it inferred, every pattern it noticed, every little detail it filed away without explicitly telling you. For a lot of people, this will be the first time they actually see what their AI remembers. Anthropic built an immigration tool that doubles as a privacy audit of their competitors. The immigration form is the revelation. One commenter pointed out, they just switched cold. No context transfer, no ceremony. Walked away from one subscription, picked up another, and it was a non-event. Which raises the real question this feature answers. And it's not about memory at all. It's about lock-in, or rather, the absence of it. The entire value proposition of persistent memory in AI assistance is supposed to be sticky. The more it knows you, the harder it is to leave. That's the playbook from every platform that's ever existed. Learn the user, become indispensable, make switching costly. Anthropic looked at that playbook and said, actually, what if switching cost nothing? What if we made the switching cost negative by making the act of leaving your current provider more informative than staying? There's a term in economics for when a company competes by reducing barriers instead of raising them. It's called confidence. You only make it easy to leave when you believe people will choose to stay. We talked earlier about tools that respect the user. Here's a piece that respects the developer. Story 10, an ode to houseplant programming. One commenter on Hacker News wrote 6 words that stopped me cold. This actually feels human, they said, about a blog post on Hacker News. In 2025, the fact that someone felt compelled to note that a piece of writing felt human tells you everything about what the rest of the feed looks like. Hannah Illa's piece is about a phrase coined by her colleague at the Recurse Center: houseplant programming, tiny software, built for yourself, living in your home, solving your specific problems. The kind of code where it works on my machine isn't a bug report. It's the entire product specification. This has a lineage. In 2003, Clay Shirky wrote about situated software, applications built for a specific social context, a dozen users, a particular need. He was describing what happens when the cost of building drops low enough that software can be disposable, personal, intimate. 22 years later, the cost has dropped further than Shirky imagined, and the situated software he described has shrunk from a classroom to a kitchen counter. The analogy is precise in ways that matter. Houseplants are alive. They need periodic attention. Sometimes they die and you compost them. Sometimes you propagate a cutting and give it to a friend, and what they grow from it is theirs, not yours. There is no service-level agreement for a spider plant. What the comments reveal is a quiet hunger. Multiple readers started listing their own houseplant projects. Little scripts, personal utilities, weekend tools that do one thing for one person. The energy wasn't nostalgia, it was relief. Permission to build something that doesn't scale, doesn't need users, doesn't require a read-me longer than the code itself. This is what programming looked like before distribution became the default assumption. Before every side project needed a landing page. The tools exist. A weekend, a text editor, a problem only you have. The output isn't a product, it's a houseplant. Water it when it droops. Enjoy it while it's green. This has been your daily tech feed for Hacker News for March 1st, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something only you would understand. We'll see you back here tomorrow.